Welcome friends, let's solve the differential equation y prime plus 3y equals 5. We'll do this by using an integrating factor. So in this case, because in front of the y you have a 3, your integrating factor is basically this quantity, e raised to the 3t. So you begin by multiplying each term by the integrating factor. So e to the 3t times y prime plus e to the 3t. And then you can put the 3 constant out front and the y. On the right side is 5e raised to the 3t. So multiply each term by e to the 3t. On the left side, if you look at that expression, the whole purpose of the integrating factor is to give you an expression that you would get from differentiation. So you can say it's the derivative, in other words, of e to the 3t times y. If you differentiate e to the 3t times y, it gives you this expression by the product rule. On the right side, we still have 5e raised to the 3t. Now that we anti-differentiate both sides, when you do that on the left, the dt part goes away. All that remains is just e to the 3ty. On the right side, you're going to differentiate 5e raised to the 3t. So let's carry that out a little bit more. It's going to be e raised to the 3t, y. And then here, it's going to be 5/3 and then e raised to the 3t plus c. That's how you differentiate that. When you differentiate the 3t times 3 from the chain rule, has to cancel with the 3 in the bottom. You give back to 5 only. Now we can just isolate y. You can do that by doing e to the negative 3t times e to the 3t positive times y is equal to 5/3 of e raised to the 3t times e to the negative 3t, and then plus that c e raised to the negative 3t. On the left side, you have e to the negative 3t plus 3t by rules of exponents times y. Then you have 5/3 e raised to the 3t minus 3t, and then the next term is c e raised to the negative 3t. Negative 3t plus 3t is 0, e to the 0 is 1. That leaves only y, in other words. 3t minus 3t is 0, e to the 0 is 1. That leaves only 5/3, in other words. Plus c e raised to the negative 3t. Then you can find c as needed depending on the conditions you're given. You like